Hello and welcome back to Mr. Powers Teaches Algebra 2, or Algebra, whatever. There's one more thing I want to go over. We had the properties of exponents we talked about, or properties of logs, excuse me, last time, all these properties. What I want to do now is talk about the change of base formula. Let's see if we can figure out this change of base formula. It's not really used much anymore. It's not really necessary. I'm not sure there's any use for it anymore. It used to be we needed this to use calculators to find values of logs and approximate them. But now almost any calculator can do any base of a log. So it's not really that useful anymore. But here it is. We do have this formula, log base a of x equals log base b of x over log base b of a. In other words, you can just choose a new base. Take log of the x divided by log of the base, and that will equal the same thing. So it's really, really handy if, say, we had a calculator that could only do log base 10 or log base e, like when I was growing up. But now we can do all the logs. Who cares? Okay, but so the way we're going to prove this is kind of be similar. My strategy is going to be similar to the way we proved property 5 up here. So let's see if we can do this. I'm going to say, we're going to say let. We're going to let log base a of x equal p, log base b of x equal q, and log base b of a equal r. Okay. Then what I'm going to do, all right, is we're going to use, again, our definition of logs to rewrite this in exponential form. Because it's so much easier just working with exponents, right? Am I right? We like exponents. We're used to them. Let's go back to exponents. So we got a to the p equals x. B to the q equals x. All right. And b to the r equals a. All right. All right, so now let's play with this and see what we can come up with. All right. So we can see that b to the q equals a to the p. They both equal x. So now we have that. So we could say, all right, a to the p equals b to the q. That's good to know. And then b, or a, okay, a is the same as b to the r. So then I could go further with this over here. I could say, you know what? A is the same as b to the r. So I got b to the r, p equals b to the q. Beautiful. All right, let's see where this takes us. See if we can get what we want. Now, what do I really want? If we're thinking about this, log base a of x is p. What I really want to do is be able to get p by itself, and hopefully what I'll get is log base b of x was q. Hopefully I'll get q over r. Hopefully I'll get p equals q over r, the way I have this set up. So right now I have it looking pretty good, I think. I think we might be able to get p by itself. So right now I got b as a base on both sides. So I think we'll be able to get rid of it. Because now we got a power raised by a power is just a product. So this is b to the rp equals b to the q. Well, and that means, right, if you have the same base, the exponents must be the same. That means rp, r times p, must equal q. Oh, beautiful. And then I can divide both sides by r. divide by r, and we get over here that P must equal Q over R. And that's exactly what I wanted. Why? Because what's P again? Let's go back and back substitute. P is log base A of x. So that was log base A of x equals Q was log base B of x. Log base B of x over R is log base B of A. And so that is our change of base formula. You love to see it. And since we did the proof here, and that was fairly quick, we got 5.5 minutes, let's do an example just for funsies. And we'll do one we know. I don't know, doesn't really matter. We'll use a calculator. Log base 3 of 27. That's an easy one. We know how to do that. So log base 3 of 27. What that means, if I'm using the change of base formula, and we know what 3 cubed is 27, so we know this should equal 3. But let's rewrite it using change of base formula. So this is let's use natural log. So natural log of 27, or log base e of 27 over natural log of 3. That should be the same thing. It should equal 3. And so let's test that out using GeoGebra. All right, so here it is. Let's try it out. First, log base 3. So I'm just going to type in log. I'm going to hit shift underscore to get my base in there. 3 of 27. It's 3. Okay. And there also is an example how to use GeoGebra here, or any calculator. Desmos works exactly the same way, I believe. And of course, there's a log function in here somewhere. There it is. I could just click on that. But let's go ahead and do natural log now. So let's try it. Natural log. Oh, actually, get my fraction there first. / Okay, so natural log of 27 over natural log of 3. Oh, my goodness. It's 3 also. All right, let's try one more. Let's try log base 2 of 13. It's going to be a gross number. There we go. So let's try it. I'll use log base 10 this time. So log of 13. Oh, let's get my fraction over. This would be the same as log of 13 over log of 2. No, I don't want to do that. I just want to do log of 2. So log 2 is a function in GeoGebra. So it's like, do you want to do a function? No. Okay, there we go. And even put it in there. Log base 10 of 13 over log base 10 of 2. 3.700. Same answer. So there you go. Change of base formula. It works. We proved it. We did some examples. Piece of cake. I hope you found that useful. And until next time, enjoy doing math.